Yes, welcome. So today I'll start with the orthographic projections. So in this case, orthographic nothing but we need to draw the top view and front view for a particular object. Now in this case it is given bracket here. So the block. So which for that isometric view we need to draw the top view and front view, and also we need to draw the side view. And in order to select this, in order to select the views, the top view, front view, and then the side view. So it's very easy, we can draw the top view and front view. And in order to select the side view, so we'll be having the doubt, side view we need to take it. That is, we need to take the direction in which we can see this direction, the object in this direction, or we need to take the direction in which view see the object, in this direction here. So for that, we need to see the condition that in any particular view, we need to get the maximum details of the object. In that way we need to select the appropriate side view here. Now in this case, when you take the side view in this direction, this is called the right side view. You'll be looking from the right direction. From the right hand side you'll be looking into. So this is the right side view. That we need to place it on the LPP, that is the left profile plane. So the profile plane, the side view plane, which is placed towards, if this is the front view and top view, so if it is placed towards left, then it is called LPP, left profile plane. Similarly, with respect to the front view and top view, if you are placing the side view towards the right side, then it is called the RPP, right profile plane, on which you will be placing the left side view, the view which you obtained from the left direction. From the left direction, when you see, that is called the left side view. Now in this case, to start with, first let us go with the front view and top view here. In order to draw the front view, it is given the length is equal to 100. It is given the length is equal to 100, and then the height it is given as 75, and then the thickness it is given as 15 here. The thickness it is given 15 here, and then the thickness it is given as 22 here. So let us go here. So in this, first I'll go with the top view here. So first I'll go with the light line in the beginning. So later I'll go with the dark line at the end. So now, it is Venus. Let us go with the top view here. So first I need to draw the rectangle for the length, 100 mm, and then for the width 64. So draw the rectangle here. The width it is 64, and so the length it is 100 mm here. Now after this, here it is, when you see from the top of this thickness, you can see the 15 mm. So for that you can go with the offset here. So go with the distance, it is 15 mm here, and it is single, and then select this and then go with the green button, and then you got the 15 mm thickness here. From this line, it is, you need to draw one more line at a distance of 15 mm here. Then afterwards, you need to draw the rib here. So for that, here it is from this side, from this face, so it is at a distance of so from here to here it is 70 mm here. Now you need to draw the in this case I'll be drawing the rectangle here. The length, the length from here to here it is 70 mm here. So I'll take 70 here. I taken the length, it is equal to 70, and then the thickness it is 12 mm here. So take the thickness 12 mm here, and here it is centrally placed. This is centrally placed in between this width 64. So for that I'll be fixing the dimension here. So from this edge to the midpoint of this, I'll be taking this as 32 mm here. I'll be taking this 32 here. So the object itself it is moved, then I'll be extending here, then go with the trim here. So trim this object. Now with this, we have completed. And then here it is at a distance of 16 mm. There is a cutout here, there is a chamfer here. So at a distance, the linear distance 16 mm. Now from here I need to draw one line here Okay, from here, so I need to draw one line. Similarly, so here also I need to draw one line here. So for that you need to maintain the distance. Okay, you need to maintain the distance. So here it is 16 mm. Okay, and then similarly from this line to this line it is 16 mm here. Okay, it is 16. Now we have completed the visible portion in the top view. In the top view we have completed the visible portion here. Then coming to the invisible portion here. So here it is not so easy to draw in the top view here. Okay, so this invisible portion, okay, this slot which is provided here, that I'll complete at the end once after, okay, I'm drawing the side view. Now so I'll go with the front view here. Okay, this is about the visible portion for the top view. Now I'll go with the front view here. Okay, whatever the features which I covered here, for the same thing I'll go with the front view here. So project all the lines here. It is for the length. Now so I got the length is equal to 100, the length is 100, and then the height it is 75 mm here. So you need to take, so I'll take the rectangle here. It is from here to this, the thickness it is 22. So this length it is 100 here, and then the thickness it is 22. So this is 22 mm. And so after that there is a vertical rectangle which is giving. So from the bottom, okay, so from the bottom it is 75 mm here. From the bottom it is 75. So take this. So here it is, I'll be trying one more. Okay, rectangle here. So the distance, okay, from this top edge to the base it is 75 mm here. This is 75. So I place the horizontal rectangle, I place the vertical rectangle. In this case this line it is not required, I will be removing this. Then so here it is, so this portion I need to draw it. So here also it is a distance, the vertical distance it is given as 16 here. Then you need to take the line here, take the line. So the distance it is from this line to this line it is 16 mm here. You can see here the vertical measurement for this chamfer. So the vertical measurement also it is given as 16 mm. Now so the next thing is the rib. The rib I need to show it here. So from this edge to a distance of 70 mm. Okay, so from the here it is, I can project it here it is. So I can save my time here it is, just for the timing I'll be projecting here. And then so here it is at a distance of 40 mm here. From the base to this point it is 40 mm here. So just I'll be drawing one line here. Measure the distance it is. This distance it is 40 here. This distance it is 40. Now I need to draw the line here for this rib. So you need to draw the line connecting, so this point to this point. Then later you can remove this. You can remove this, and then you can remove this line. So this will be the front view for this object here. This will be the front view. So if you want, you can show the dimension here. From this line to the end point of the line it is 40 mm here. Okay, this is the visible portion. Then afterwards, okay, I need to draw the side view for this. So for drawing this, I told this is the LPP with respect to the front view and top view. I am drawing the side view. Okay, that is a profile plane towards left. It is called LPP. So draw the vertical line. So draw the vertical line. So from here you need to draw the 45-degree line. It is always for drawing the side view you need to take the 45-degree line. Then in order to complete the side view here, so first we need to project it here. So project the points from the top view until the XY line. Okay, first I'll be going with a boundary line here. So and then you need to project it upwards, like how you did it in case of the side view method. So the same way you need to do it, and then here it is the height of the object, and then here it is the and then here is the level of the stiffness. Okay, this is about the side view. So this is about the visible portion of the object, and this portion it is not required here. It will start only from this level. So then after this, okay, this is the visible portion which we got it, and then here is a chamfer here. Here is a chamfer for 16 and then 16. I need to go with the chamfering, so go with the chamfer here. So take the edge and then take this edge. You need to give the 45 degree setback A, it is 16 mm, and then setback B, it is 16. Now here it is, we need to go with the chamfering between these two. So it is setback A I given as 16, B has given as 16, because here it is the vertical measurement it is 16 and then horizontal measurement it is 16. So just click it here so that this portion will be trimmed off. Same way you need to do it on the other side also. So go with the chamfer, select the first side, select the second side. Same way it is the always it is a standard angle. If it is not mentioned, by default you need to choose it as 45 degrees for this, and then it is same thing, it is chosen. It is by default it will be choosing the previous measurement 16 and then 16. Yes, it's correct. The vertical and then horizontal measurement it is 16 and then 16. Just click it here. So this portion will be trimmed here. This portion will be trimmed. Now, so coming to the invisible portion, here it is. Okay, this portion when you see from the top and then front, it is invisible. So how to get this? So for this, it is given 60. Okay, so this measurement it is given as 30 mm here, and then the height it is given as 12. Okay, at a distance of 12 mm, the height you need to draw the 30 mm line here. So now go here. So here it is, we need to start from the side view. So at a distance of 12, you can choose this. So I'll be trimming this portion. Here it is, I'll be getting the midpoint here. So from here, so the midpoint you need to draw the line, and then so from this line, okay, here it is to the end point of this line it is 15 mm, and then the other side it is 15. Okay, total it is 30, and then this vertical height, okay, between these two it is 12 mm here. Okay, it is 12 mm. Now, so after this you can see here in the sketch it is 60 degree. Okay, from here you need to draw the 60 degree line so that it will be touching here. Now, so here it is, so there are alternate angles. Now here it is, from here I will take the 60 degree line here. So then take this, if it is 60, this is 60 here, and then similarly here also you need to take 60 here. Then trim the extended portion here. Okay. So this line we can trim it off. So this you can show it as a whole, the 30 mm. Okay, so this is the slot which you need to show it here. Okay, this is the slot which you need to show, and then here it is. So you need to refer it back. So this is the line which is invisible from the front view. You need to trim it. Okay, trim this line, and then this portion will be invisible. This portion will be invisible. You need to convert this one to invisible line, and similarly you need to project it onto the top view here. So for that, let us check it. Okay, it is 60. It is given the 60. There are alternate angles. You need to, since it is 60, this is also 60 because they are lying between the two parallel lines. So for that we need to take 60 degree here. So you can retain this and then you can delete it because it is given in the question. Now it is, you need to project these points onto the top view. So take this. So trim it. So okay, this is applicable for the entire length. So I need to trim this portion here. I need to trim this portion here. So this is okay. These two are the extra lines. I need to trim it. These two are invisible lines. This is invisible, and then this is invisible. And here it is. These two edges are invisible here. You need to project them. So you need to extend it here, until the end. And similarly from here you need to extend it here until this, and then you need to project it here. So trim the extended line here. So this is not required, and then here it is not required. And so this line should be invisible, this and this. And then this portion should be invisible, so make it into invisible here. It is this portion, this portion we cannot do it in the front, top view and then front view, because we will not be getting the details. It is given the angle here. This angle always stand for the side view. This angle always stand for the side view. So for that you need to go with the side view only. So this measurements, the dimension you can drag it outside, so that we can convert all the lines to visible line at a time. And then these projection lines you can delete it, so that we can convert the drawing directly. So these lines will be visible here. It is, we need to make it dark, the visible and invisible portion. So make it with 0.5 mm thickness here it is, so that we can see the visible portion of it. Similarly the front view, see the front view also you need to make it dark here. So shift this dimension outside the drawing. Now we can select the drawing. And then make it into 0.5 mm thickness, so that here it is only one line, it is invisible. In the top of these four lines, these four edges, 1 2 3 4 edges, they are invisible in the top view. And then here also it is, so this portion it is visible here, except this dimensions we need to change everything to 0.5 mm thickness. And then here it is, this boundary should be dark line. Okay, should be dark line here. And here it is, there is an opening in the side view. So for that you will need to trim this portion here. So this portion should be trimmed. This portion should be trimmed. Here it is. So this is about the orthographic projections, converting the isometric view, the 3D object, into 2D object. So here it is, you will be getting, in any view you will be getting the two dimensions, the length and breadth, and then the length and the height of the object. So same way, so this is called the studying the drawing. So you need to see that for any object you need to see the length and breadth and then the height. Okay, those three dimensions are given, then you can split up that object into equal or simplified parts, and then you can continue. So by changing by in conversion of this isometric view into the orthographic projections. Orthographic projection nothing but drawing the top view and then side view for this. Top view, front view, and then side view for any object, it's called the orthographic projections. So it is, so it will be useful for the manufacturing here, for the fabrication. So this part, how they can split it, in order to analyze the drawing, they need to convert this, working drawings. These are the working drawings. So so these are the working drawings. By using the 3D object, they will be converted into the working drawings. So here it is. So for the naming, so this is called the front view, and then this is called the top view, and here it is the side view. Thank you.